Hello, this is a Roc Hangout session thing. We're doing some app development. It was George's idea. George is new to the Roc community. I am medium to the Roc community, and we've got some Roc veterans in here to help us out if we get stuck along the way. If you're watching this later, hello, thank you for joining. Roc is a new programming language, work in progress, version 0.0 right now. We're hoping to have a 0.1 next year in 2023. But for now, you can do a lot of fun things with it, and we were going to give that a try. I've been making some Roc apps for a few months and been really enjoying it. And George is new and wants to start developing some apps as well. George, did you want to say anything, introduce yourself?
Sure. Hi, everyone. I'm less new in the Elm community, and I've been taking an eye on Rock for quite a while now, as a lot of people. And I wanted to try to use Rock to build Elmbook CLI, which is basically a sibling application for Elmbook. And I talked to Jen about just using Rock for watching a few files, reading from them, writing in other places, something that is really, really simple. And I thought that it might be a good fit for trying out Rock as it is right now. So that's what I think we are going to be doing today.
Yeah, that's the goal anyways. We'll see what happens. We've got about an hour here, so we'll see how much progress we can make, see what sort of fun compiler surprises we run into. I think that all of the surprises should be ironed out. Thank you very much, Richard, for helping me out last night, getting some features in that will help us today. So I'll share my screen, and we'll go from there. Okay, so this is the Roc programming language repository. It is a work in progress. It is not production ready. Please do not take this session as an invitation to build production grade Roc apps. That is not the intention at all. The intention is fun and playing around and learning and dreaming about the future, because the future of next year could be that. We'll see. So with this repo, what you want to do is you want to clone it. So I'll go ahead and do a fresh clone so that you can get the examples and such. Roc lang, Roc, and I've typoed github.com. And this is going to come with source code for the entire compiler and command line interface for Roc, but it's also going to come with example applications. We're not going to compile any stuff from source today. We're not going to build the Roc CLI. Rather for that, highly recommend using the nightly release of Roc that is built for you for your operating system. I believe in the near future, we might have some Windows stuff in here. I won't speak for anyone on that, but for now it is Linux x86, Mac x86, and Mac M1. So I'm going to grab the Mac nightly build here, download it, and if you want to follow along at home, you are welcome to do so. This one was built yesterday. And I'm going to move that from my downloads directory, or desktop rather, if it's set to do that. There we go. Into my local bin directory on this machine. Head over to local bin and unzip it. Note from Brian there. Untar that, and now I'll get a bunch of files into my local bin directory, most notably this Roc file. And I already have in my path that I want my local bin directory to be used for finding executables. So that means now if I say which Roc, I should get local bin Roc. So now we can do fun things like exploring the Roc REPL, the read eval print loop. The developer can't be verified. Maybe it's malware. Maybe it's Maybelline. Let's head over to system preferences and turn that off. I believe that would be in security. General. Allow anyway. Now, Roc, are you allowed to exist? Hooray! We've got a read about print loop. The good news is the number 123 is in fact a number. So once you get the Roc REPL or the Roc nightly build installed on your computer, then you can use things like the Roc REPL. You can start doing expressions that you would expect to do in something like a Python REPL or maybe a Node REPL, where you can use it as kind of like a calculator. But you can also use this as a way of stepping through the Roc tutorial, which is here in the repo at tutorial.md. It is a really thorough tutorial on the syntax and features of the Roc programming language. I'm not really going to go into it today. I'm going to leave that as an exercise to the reader. This session is going to be more assumed that you've gone through this, you have some familiarity with the syntax of Roc, and then you can join us in making an application and trying out the CLI. Any questions so far, or shall we dive into one of the more complex and recent Roc examples of applications and modify it to George's plans and needs?
Not for me. Let's do it.
Awesome. So I'm going to be coding inside Visual Studio Code. It's a handy IDE text editor for me, just so that I can see files. I'm not as skilled with the terminal as many other people are, so I just like having the GUI. I'm just using it for GUI functionality. It's worth noting that Roc is working on a really awesome editor that is going to be leaps and bounds above any sort of extension or language integration in an IDE or text editor like VS Code. But for today, a simple text editor, whatever you have, Nano, Vim, is going to be a good environment for working in. The thing I want to draw your eye to is the interactive example called file.roc. And George, do you see this app in your repo?
Yes. Just so you know, like right now, I'm trying to compile everything from my side as well.
Oh yeah.
But I'm following things on your end, so we can keep going on your side. Please.
Awesome. Yeah, I don't want to leave you behind. I think the goal of this is not so much for me to monologue about wonderful ideas, and more for us to get into the nitty gritty of how to debug when things go wrong.
So
Sure.
just a general note for people. Roc maybe does or doesn't have syntax highlighting now. I think someone made an extension with Roc syntax highlighting specifically in VS Code, but I think
Oh, yeah.
most of us still either use CoffeeScript or Elixir syntax highlighting because that was close enough. I haven't tried the Roc syntax highlighting extension that someone made, but I guess that's worth seeing too.
Yeah, let's give them their laurels and install that. I really appreciate them making it. It's incompatible with the current version of Visual Studio Code, so thanks for making it, but either I'm out of date or it's out of date, and either way, that's fine. It gives you basically the same thing that CoffeeScript syntax highlighting has, like Brendan mentioned. It just needs to be something that's close enough so that the symbols look about right. And it's probably a good idea for me to turn off my goofy font that has ligatures in here that turns characters into like hieroglyph looking things. Let me find my font settings. Maybe a system level thing. Oh man.
It'll be fine. I wouldn't worry about it too much.
Okay.
Probably a lot of people are used to ligatures, but
okay. I feel bad for doing these ligatures, but it's really just these two characters next to each other that a font is combining into an arrow looking thing, and these two characters next to each other that my font is combining into a triangle looking thing. So it'll look a little fancier and weirder than in your text editor, but it's the same idea. The point is for these ASCII characters to kind of visually turn into these symbols and hieroglyphs in your eyes anyways. So as a quick summary of what we're looking at here in this code, I will walk through the code and basically say it in English, what's happening at every step along the way. And if you have any questions at all, anyone on this call, please stop me and ask, because your question could be hitting at some core thing about Roc that maybe you haven't seen in one of the YouTube videos that I'm assuming everyone here has watched all of the YouTube videos and gone through all of the tutorials. So please stop me if there's some assumed knowledge that I'm skipping over. So this app is called file.io. Most notably, it's going to create an executable with that file name. So when we compile this into an executable, which I will go ahead and do right now. We'll cd into this directory, and I will use the Roc CLI to build examples interactive file.roc. And it's going to rebuild it along with its platform, which is something I'll explain in a second. And then we'll see a file show up here that should have the file name file-io.
Yeah, right now it's probably what, you running cargo and rebuilding the world from cargo's side, which is
The entire
probably
world.
going to take a second, you know.
Okay, that'll take a second. There will be a file that will appear here, file-io. Second line of this app is saying that we're going to need a platform from CLI platform / main.roc. Roc has this concept of platforms and apps, and if you want me to dive into that right now, please ask. The idea is basically in the same way that if you build a website with Flask or Django on Python, or you would build some web server with a Rust web framework, that framework is kind of like your programming language because you don't just write raw Rust or raw Python, you write a special version of it. This is kind of the same idea, where we're going to be making a CLI app, and so we need a CLI platform. But if we were going to be making a GUI app, then we would want a GUI platform. If there's any questions on that, I can dive deeper into it. But the third line tells us that the CLI platform gives us features like standard out, standard in, standard error, tasks, which I'll explain later, files, you're familiar with file system, path in your file system, environment variables, or actually I think end is for getting like your current working directory, and then directories for perusing directories. So these are sort of the primitives that you're going to want to have for doing any sort of CLI type application. And that is specifically what we're here to build today with George. Yes?
The imports line, this lists out the modules that I'm importing from the platform, is that it?
That's correct.
But those modules are still written in Roc, but they have access to native how can I say it, native functions or an identifier or something like that. Is that it?
That is exactly correct. Because the CLI platform has, the only way for us to talk to the file system is through this file module that the CLI platform has exposed to us. And the only way to write to standard out is to interact through the standard out module that the platform has exposed to us. The platform has basically a Roc wrapper or a Roc API around lower level features. And if we were to go into this, we would see these modules, but we would also see, we've got some C code, we've got some source code here, which is written in Rust. So we've got some things here for memory management, for file system interaction, and we're just sitting on top of all of that. We are not interacting directly with memory. We're not interacting directly with a file system. We are interacting with the API that the platform has exposed to us for doing those things.
Got it.
And the fourth line here is saying that, hey, the platform is expecting to call a main function. Here is my main function. I've called it main. Now getting into line 6 is where we start to get into the real Roc app code and not just this header. Oh, by the way, file-io did build. I presume that the second time I would execute that command, it would be a lot faster, and it would be even faster if I used a pre-built platform and skipped that rebuild step. So if I go here and say, let me expand this out so that it's not so smushed into the side here. If I was to Roc build pre-built platform equals true, and then build that executable, it would be much faster. Because building the platform is only half of the app building step. All right, getting into the Roc code here, we've got basically a type definition, type declaration, type signature for our main function. What it's going to do is it's going to, this isn't a function, this is a expression that expresses a task that it wants the CLI platform to perform. And a task is basically some interaction with the outside world. And it could be a chain of interactions with the outside world. In this case, we have a bunch of different things that we do. We've got some standard out writing, we've got some file system operations, we're getting the current working directory. But at the end of the day, we're returning all of those tasks chained up into one mega task that the platform is going to operate. And so this basically means that this CLI platform knows how to talk to the file system, knows how to read and write to standard in and standard out, but it's asking Roc what kinds of things it should do. What's the task or tasks that it should perform with that capability? And we're defining in Roc essentially the business logic or the application logic for what that platform should be doing with the file system, with HTTP, with standard out, stuff like that. Does that all make sense so far? It's a lot compressed into a small space, so I want to pick at it if there's something that's bothering you.
For me, at least, everything is perfectly sane. I have a question though. I'm pretty sure that you're about to get to it. But
Sure.
on line 5, there's task. There are a few like there's this empty record. There is this empty list, and then I have something that is. I'm kind of like curious about what that is. Like, am I listing the possible errors of my task or something like that?
This is essentially the set of results that it could have, or the set of tasks, I believe. Let me check. So the task signature, the first one is going to be what it returns in the OK case. The second is the error case. Brendan, what's the third argument to the task type definition again? Oh, the effects it does. Thank you, Richard. So
yeah, good thing Richard answered. It's new. That's what I was going to say. So I don't actually know.
So this is essentially the set of interactions with the outside world that this task bundle could result in. It could result in writing to the file system and writing to your terminal. It could result in reading from your file system, and it can result in interacting with your environment like your current working directory.
Is this so that we can know that a particular application is not, like, maybe I'm giving it access to read operations, but not to write, or maybe it's not allowed to use HTTP or something like that. So I'm making it explicit, even though the platform like gives me all of those choices. I'm still saying that my particular app is only using like a subset of that.
Yes, that's a part of it.
Yeah, so just as an example here, you could make a sub function that says it's called read file, and you could make sure it only has read file there. And so you know it will never return a task that does anything else except for, file IO. That is the only possibility there, or like reading from a file, not even writing, right? So if you saw that, it's not going to return anything else, right?
Got it. So even though it's an IO function, it's kind of like unsafe operation. I still completely know what it's doing, right? It's not like IO and everything is valid inside it.
Exactly. Yeah. So it's scoping the IO, like what's allowed.
Awesome.
I'm going to smush this farther into the side and collapse this a little bit more so that we can do some font size increase in case anyone is having trouble reading the screen. I don't want it to be difficult in any way. And similarly, I'm going to update my settings so that I don't have relative line numbers on. I just noticed when you were mentioning a line number that it was a funky line number because I had the line numbers being, whoops, I just turned them off, relative to where my cursor was. So I'm going to set that to a more sane setting here. There we go. Okay, now we can all talk about the same line numbers and not be dependent on where my mouse happens to be clicking. Okay, so moving on to the next lines here. There's essentially a couple of different groups of code here. The first one is just a declaration of a variable called path. And this is going to be talking about our output file, which we're calling out.txt. Then the second group here is defining our task or our task chain that we want to be interacting with the outside world, the tasks that we want the platform to perform with I/O on our behalf. And the last chunk here is what to do with the result of those tasks. There is room here in your function declaration to say, I had serious problems. This is not actual code, this is pseudocode. But you would in here say that you had some error, maybe file not found, or you had, terminal busted. I don't really know what would be going wrong, but there's room here for things to be going wrong, but not in the main function that you pass to this platform. This platform expects anything to go wrong to be handled by you, the app developer. So it needs you to tell it what to do when these things happen. So for instance, if you were to get a file writing error with permission denied, you're going to tell the platform, here's how you handle that error. You're going to say, standard error, write this permission denied message. Or if it's unsupported operation, then standard error, you're going to have this unsupported message. And this is essentially, not only do we have to declare all of the interactions we can have with the outside world and all the effects, as they're called, we also have to declare every reaction to things going wrong as well. And if we don't, that's a compilation error. And so with Roc, what you have is not only compile time error messages for, you're doing something with the outside world that you're not allowed to or that you didn't say you were going to do, or vice versa, you're not actually doing these things that you said you were going to do, but you also have, hey, you didn't handle this failure case, or you didn't handle any of your failure cases. And so Roc can kind of guide you by having you write your error handling in this task error callback way. Does that all make sense so far? At a high level, not at like a nitty-gritty syntax level?
Perfectly.
Wonderful.
Thank you.
So now if we look inside of this task chain, we'll see a couple of other groups of code. The first group is, and you can kind of think of every arrow pointing to the left as its own little group that we want to take a look at. So I'm going to group things by the next left arrow that we have. So let's look here at this first leftward arrow, which is, we want to get the current working directory. End.current working directory, end.cwd, is going to give you a task. And so you could return that from this main function as like, this is the task that I'm doing, this is the last thing. But we want to do things after that. We have these other tasks we want to perform. So we pass that result to task.await, and then we put this backpassing arrow on the other side of it. And this syntax is fairly fancy, but essentially what this is doing is the equivalent of end.cwd, and then I want to wrap that in task.await. So you can think of some parentheses in here if you're coming from a language that has parentheses for function calls. End.cwd, the result of that is going to pass to task.await. So in JavaScript land, you could think of this as await some async function. And then once you've awaited it, await has another thing, which is what to do after. This is the callback function. And we would define that to be, all right, I've got my current working directory, and now I'm going to do something with it. I'm going to say, concat that, or I'm going to print that, or I'm going to move to the next step. And the problem with this is that in a task chain where we await this and await that and take the results of each of those awaits and pass it to the next one, pass it to the next one, we would end up with a whole lot of indentation. And that indentation in those callback functions is fairly ugly. And so what we do instead is we take this arrow and flip it around to this side. We do cwd backpassing task.await, and we dedent everything else. So whenever you see this arrow here, you can think of it as the callback function on the right side with indentation moved onto the left side with no indentation. Does that part make sense for how backpassing fits into the syntax of the language?
Yeah. Just so you know, so task await in this scenario is also kind of like an alias to task.map, right? Because it's the same function. Well, the same goal at least, right?
Yeah, you're referring to the idea of it being kind of a monadic bind.
Yeah, like in the for the Elm developers that are here. So
yeah.
it should be.
I am not one. I want to clarify. I've never used Elm before, and so it sounds.
Okay. Yeah, but it should be the same, right? Like this task await is not actually saying that this is a synchronous call and I'm like pausing my process here. No, it's I'm just like wrapping it in a map that is changing the return value, right?
That's correct. Yeah.
Okay.
And so this map.await is basically, you can think of it as kind of like a chain with other thing I want to do, but instead we just call it await because that's the convention in programming languages like JavaScript to have await be the thing for take some asynchronous operation, and in the context that I'm in this function, I want to make it synchronous, make it look synchronous, even though it actually has an asynchronous process behind the scenes. And it's worth noting that this strange triangle, for anyone who didn't hear my sorry for my ligatures font earlier, this is basically just one, let's say like 1 plus 2 equals 3. We all agree on that. But there's a num.add function in Roc that you can use. So you can use this instead, num.add 1 and 2 equals 3. We're all still good with that. If you want to have some pipeline of, oh, then I want to add something else, then I want to add something else, you would have to be like, oh, num.add of num.add 1, 2, and then 3 equals 6. This is starting to get ugly. Let's simplify it with the pipe operator. So 1, pipe it to num add 2, pipe it to num add 3, and that equals 6. So this pipe operator is, if you're coming from another language that has it, probably fairly intuitive. If you're not, it's kind of similar to this backpassing thing that I just explained, where we have syntax that gets into a spot that we don't like. And so instead, we syntax ourselves out of that syntax hole that we're inside of. So instead of having these function calls on top of function calls, we move it into a very linear logic where 1 and then you add 2 and then you add 3, similar to how we do this task and we get the current working directory, and then we do this task and we get the directory entries. We're trying to make things as linear and smooth as possible. I'm going to delete all of this to go back to the original code, which is we have this operation here, get the current working directory. And by the way, if you don't like acronyms, you can see it as this. Environment.get current working directory, but it's abbreviated m.cwd. Then we're going to await on that, and then we're going to get the result as cwd. Now we can go over here and use this path.display function in order to turn it into a string, because I believe that cwd is not a string itself, it's a path. And it would be helpful for me here to put some type annotations on this. I believe this would be the type annotation for it. And I'm just hacking through this. If anyone wants me to, try running some more specific code, happy to do that. George, yeah?
Yeah, I was just wondering, does Roc already have anything similar to, I know that you don't know Elm, but like a way for me to debug a structure in the middle of the code so that I can actually like take a look at what path looks like if I want to debug it instead of like looking at the code itself?
No, it does not. The plan is for that not to be a language syntax level feature, but rather an IDE feature where you can instead hover on or select some variable in that and then see what it is at some part in the execution, and the entire debugging user experience, developer experience is going to be centered around the editor rather than centered around the compiler.
Got it.
That's true though, Richard is right. There is one sort of break glass functionality, which is expect cwd string to equal foo. I can put this in the code, and this is sort of like a macro where it's going to panic the entire Roc application. It's going to crash the entire Roc application if this does not evaluate to true. So we can run this and we can have some expectation. And I think there's a way to do like a comment. Maybe there's some string argument to it. Oh, it keeps going. That's even better. Thanks, Richard. Appreciate that. There's ways to do like expectations and the equivalent of like a print or a debug in the middle of the program, it sounds like. I've only been thinking of the expect commands as being used for the Roc test subcommand of the CLI, where it will go through your app or your directory and find every usage of expect and test that they're all true. And then it'll be like, well, all of your functions are tested, green light is go, but I didn't think about using them for functionality of debugging. That's great.
And would it show up in the actual build process, or would I need to kind of like run an application for me to see something like that?
Let's see.
It would have to be. It would have to be run in this case, because you either have to run the tests or you have to run the actual application for the expect to run. Build wouldn't know if it passes or fails.
Yeah, yeah.
Nice. Should work just like debug log in Elm, says Richard. Thank you very much for all of the support, all of the more knowledgeable platforming and Roc people here. I'm just a Roc app developer. There's a whole other aspect of this of Roc platform development that I'm completely novice on. And so if anyone has any questions, highly recommend hitting up Brendan or Richard in the, or Ayaz, who's also here, in the Roc Zulip chat room. They will be able to answer your questions about the Rusty stuff, the Ziggy stuff, and the CE stuff. I can't. All I can answer is the Roc stuff. All right. So here we've got this string version of the current working directory, and we're going to, you know what would be really helpful as we're working through this code is just having in the sidebar what it looks like when we run this code and it prints it out to the standard out. Why don't we do that? Why don't we run so that we can see
It's gonna fail.
Oh,
Because your type declarations aren't technically correct because it's in a lambda.
thank
Yeah,
you.
for that one. But now
Thank
it
you
should
very
work.
much. I save here. We're going to run this. I should have done it with pre-built platforms so we didn't have to wait for the rebuilding of the platform every time. That's to make sure that if there's any changes from your platform developer support, then it should get picked up in here. Great. This is actually correct. It goes through and it lists out, this looks like an error message, but it's not. This is what it's doing. It's going through and listing the contents of the directory after saying what your current working directory is here. So this is the step in the code that we're at right here with this standard outline. Going to print that current working directory. So it got that current working directory as a path from the environment module, and then it turned it into a string using the path module, and then it used the standard out module in order to print it out to terminal output. And then it moved on and said, well, I did that. I didn't need to get any return value from that, so underscore whatever is the result of this. I believe that the exact result value would be something like an empty record because standard outline doesn't care about giving you a return value. And then it would move you on to doing the next set of tasks, which is getting the directory entries. And so the directory module provides this list function, and all you need to do is give it a path, and it gives you back all these entries. And then we're going to do some fun mapping logic. I'll go ahead and smush the sidebar again so we can take a closer look at this code. Sorry for all these new lines over here. We're going to take all of those directory entries, and then we're going to map them into this display thing. And actually, I'm going to rewrite this code into the way that I would write it as an exercise in learning about Roc pipelines. So I think that a more intuitive way of writing this is saying, let's take our directory entries and pipe that into list.map. And what are we mapping? We're mapping the path.display function. And then we take the result of that, and we're going to pipe it to string.joinWith. What are we going to join it with? New line and 4 spaces. We're going to take the entire result of this and assign it to the content string. So these two lines, at least I think, should be equivalent. And hopefully that helps show you what the pipeline operator does and how it rearranges syntax in order to make it linear rather than nested. So what content string is, let's test it. Let's see if I'm right or wrong.
You'll have to comment out the old line.
Thank you very much. Programming at its finest. Pre-built platform equals true. Comment out the old line with.
So there's no shadowing, right, in Roc?
Yeah, Roc will give you a compiler error if you shadow.
Okay.
It works. Let's shadow and see what Roc does. Boom. We get a duplicate name compiler error. Very nicely formatted. Thank you to all the people who have made all this formatting so beautiful. I don't have any like terminal extensions or anything installed, so this is just like the out-of-the-box behavior. So it's defined a first time here and a second time here. That will not fly. Let's turn that into a code comment. And then we will rerun it. All right. All right. So now we have the contents string, which is this new line joined and indented directory contents thing. We write out to the standard out directory contents, and then that. Then we write out, hey, I'm going to write this string, and then it uses the file module. Thank you so much, Richard, for making this in the last 2 days, these file write and file read functions, because now we can do file operations. And it takes the path to that output file and writes the text a string. Let's confirm with cat out.txt. Oh yeah, we're good to go. Then we're going to read the same file, bring in the contents, read it back, and its contents are a string. So we're good to go. Richard says anyone can do it. It's true. It's not really, Richard added this stuff in his capacity as a platform developer on top of the programming language that he is also a contributor and creator and maintainer too. But it's true, if you're a platform developer, you can write your own CLI and say, I don't like this file module, I'm gonna make my own, I'm gonna make it, write UTF-7s, I'm tired of these UTF-8s. Sure, go ahead.
I don't want to change the subject of this
Please.
of this chat to be about platforms, but just so I know, right now that we already have like a few platforms running, for someone to create a new platform, would I need to dive into like the nitty-gritty of, I don't know, handling a record structure or something like that? Or could I actually just deal with the actual IO functions and that would be okay?
So it depends what your platform needs to do, but you'll have to deal with some of the FFI, right? What's being passed back and forth. And we have Roc Glue that's being worked on and does a lot of it automatically, like the generation automatically, at least for Rust. But it's still definitely a work in progress and can't convert everything yet. But definitely, if you just were like, oh, I already have the CLI platform and I want to add a few extra functions to do more types of file IO or to like parse it, I guess not parsegation, that'd be a bad idea in this case because that'd be more complicated. But like, if you wanted to add some extra things like do a web request and return a string, right? You already have all the types defined there and in existence, right? Because it's really string to string is the ultimate function there. And so in that case, it would be relatively easy to add it.
And Richard here says, platforms don't define what a record means, they define what IO primitives are available and also how memory gets managed.
Got it. So
Yeah, oh, go ahead.
No, please.
Yeah, I was going to say you still have to understand the record type though, so you can actually use it in your language, right? And so like if we pass a record to Rust, you have to know how to parse that. And Glue can automatically generate that for Rust. But if you're using Zig as your platform because you like Zig, you have to learn how our records are represented in memory and write that out to interact with it correctly. And so there are some barriers.
Okay, so the actual like FFI is not really just like, okay, it's going to be the same record in Rust and in Roc, but if I want to create like a game engine and I already know how to use Batty or something like that, and the actual IO between Roc and my game engine is something simple, then I'm pretty much I'm in a good path, right? Like I don't need to like recreate the wheel. I can just like reuse whatever is available in Roc.
Yeah, exactly. Like you could have a Bevy game engine, and then you could make a bunch of functions that are like your drawing primitives, and they're only taking integers and things of that nature, and that all works just fine, super easy to do. Yeah.
Awesome, thank you.
Yeah, great questions. Tangents, welcome. Before we switch gears into building an Elm book clone with this, any questions from the rest of the people here? Any confusions or clarifications we'd like to make? Feel free to type them in the chat and we will come back to them later then. All right, so let's make a copy of this called clone of Elm book. call it the mimic. I like that word. And we'll call this Elmbook mimic. And I'll go ahead and start out by just building it to confirm nothing really has changed. It's just a different file. It's still using the same platform, so we can still use pre-built platform. It should do all of the same things that file.roc did. Yes, despite the indentation carryover stuff of it being smushed on the side of my screen, that is what we want it to look like. And so now we can go in here and George, I figure, oh yeah, go ahead.
Sure. I'm sorry. This is like the previous question, but you are inside the Roc directory, right? Like that you actually cloned.
Yes.
And is that platform path, like CLI platform main.roc, is that something that is related to that? Or if I want to create my Elmbook mimic project in my own, like, I don't know, my user code Elm whatever, would I use the same path, or would it need to be related to that actual Roc repo thingy?
I'm going to find out. So let's move this examples interactive Elmbook mimic.roc all the way up to the roc root directory. So now it's right here, this Elmbook mimic.roc. And actually, since I'm not using anything of like Nix and cargo stuff, I'm actually going to go one level up and move that Elmbook mimic to this upper directory. So now it's outside of the roc repo entirely. And we've got the roc executable, which is also outside of the roc repo entirely. I want to put that asterisk on this because if you are doing development on the CLI, if you're recompiling from source of your roc CLI and your roc compiler, then you're going to likely want to stay inside of the roc repo when you're doing these things because you'll probably be inside of a Nix develop shell, or you'll be, doing something else that's going to want local paths. But if you're not, and you're just in a project directory like we are here, and your roc is installed system-wide or user-wide like it is here, we should be able to run this. And it will fail because that platform path is wrong, as you mentioned. So now let's open that up in Visual Studio Code. I'm going to open the file that's outside of the directory that we're in. Just double-clicked on a directory. That was a mistake. Let's undo that. I want this to be the directory that we're in, but I want to open up a single file from it rather than using vim on the command line to edit it. All right, so I keep double clicking. Why do I keep double clicking? All right, whatever. I'm going to leave it as that is the directory for Visual Studio Code. That's a fine directory. We will still be able to see the file. Scroll up, close this roc repo. We've got it outside of the roc repo, and so we're going to need to change this path to point to the correct spot that the platform is, which is inside the roc repo, and this is relative to this file, examples, interactive, CLI platform, main.roc. Now if we rerun it, I forgot for the pre-built platform, so it's going to take a little longer. There we go. We've got a new set of directory contents. Yes, George.
Yeah, awesome. Just so you know, so this is something that is expected to become more integrated into Roc's package management in the future, something like that. So like instead of like searching only locally, it will fetch from whatever. Is that it?
That's correct. Instead of seeing packages local path here, you would see something like packages roc CLI friend or something like that. It would be like the name or the nickname of a platform, of a package, or maybe it would be a GitHub username. It would be like my username or Rocklang's username, an org name, or maybe it would be a URL. That stuff is not decided yet, and so it's not. I'm not claiming the syntax of this, but the idea is that it wouldn't be local; it would be remote.
Awesome, thank you.
You bet. Now we've got different output because we've got a different directory, which is awesome. But for this Elmbook mimic, we don't really need to do all of the logging that we had. So let's go ahead and get rid of this standard outline. Let's get rid of this standard outline, this standard outline. Let's get rid of the file writing. We'll keep the file writing for now. We can get rid of this standard outline. and the read. We could just have the last step be writing that file. In fact, we could probably just run this as is. We'll have less tasks. Basically, all I've done is I've deleted a bunch of tasks from the task chain. Ooh, and forgot to get rid of the last await. Ooh. Unused variable, delete it.
You picked the wrong variable there.
I did.
It's command stir. Or
Oh,
change working directory stir. Yeah,
they're
CWD
both
stir.
they're both unused.
Oh, both unused. Yeah. Okay, that's fair. I didn't see that.
And directory entries is unused as well since we're not logging that anymore. And actually, this whole current working directory is kind of unused now, so let's get rid of it. And now we're not using, as many modules here, so let's get rid of them. We're not using the directory module anymore. We're not using the environment module anymore. We're still using path, so we can keep that. Essentially, we're just trimming this down to form a more simple foundation to build our app from. So all this app does is it has some path to the output file, and let's call that output file. And it's got a task, which is to write that UTF-8. And then as a result, we've got all of these error handling. Yes, George.
Yeah, I remember Richard mentioning something that Roc doesn't want to block you from development when there is something that is not completely perfect in the code. And I'm just wondering if this problems of unused variables was just because we were trying to build the whole application, but there is some sort of, I don't know, development mode where it would be fine. How does that work? Do we have two modes or something like that?
Yeah, so there are a couple different commands here. There's a few things we could use. One is just doing roc of Elm mimic, and that is going to say, whoa, whoa, you've got some, oh, that's actually a valid compiler error. Underscore not, yeah, that's true. Old habits. So there's the roc command, then there's the roc run command, and the roc dev command. And maybe I should not be telling people, Richard, about the roc direct, because I think that's reserved for something else that's happening. But instead, we've got this roc, let's still do the pre-built platform of the Elm mimic. And the command we're going to use for this is dev. And that's going to be doing type checking and other things. So let's declare a variable here called unused that's just number 123 and see what happens in roc dev mode. So in roc dev mode, we have it unused. And it says you can run it anyway with run. And so then we head over to run and run it anyway. And what this is doing is in the compile step of compiling your application, it's going to give you any sort of type errors or unused errors or linting issues, helps and warnings in standard out, or I'm not sure if this is standard error or standard out, but it's still going to run your application for you. And now that you've run it, well, rather now that you've compiled it and then run it, you have done that compilation step of creating this Elm mimic app, which you can just run directly because it's just a direct executable at the end of the day.
Oh, so the roc run also generates the final binary.
Yes, every roc execution command like dev and run are all going to compile first as a normal compilation step.
That's going to change because we'll just do it in memory eventually.
Oh, okay.
That's the theory, at least, right?
So then what you would do instead is you would do a build step with the roc build command, which is going to tell you, you got some problems, you got some warnings, but it's still going to build it for you, and then you would do the executable directly. So
okay, so even the build one does not block you when you get some errors. Is that it?
Correct.
I was under the impression that if we had any unused definition or something like that, then we could not get the final.
Nothing ever stops you.
Okay.
Roc dev doesn't proceed with building the app or running the app but it suggests that you can change the command you're doing. But that is rock dev is the safe one. Yeah. True. All errors tightness matches. So if I put output file here is a like an I32, it's a 32-bit signed integer, and we do this dev, it's going to say, excuse me, you got an I32 over here? I can't write an I32.
Got it. Okay, awesome. Thank you.
Yeah, good question.
I know that we are getting to the end of the first session here. One thing that was in our initial like to-do list, and I don't know if it's already like available in any way, but could Roc read from the actual arguments I'm giving the Roc binary? Like if I'm gonna, I want to give it some like output folder for whatever it's doing. Is it that available in any way in the platform?
Yes, I believe that's coming. Is that right, Brendan? That or Ayaz?
So you can already do it. I don't know if the CLI platform has it, but you definitely should already be able to do it and just like pass args, sort of double dash at the end and then pass more args to the application itself.
Yeah.
Oh, okay.
PR 3990 isn't in yet, but that's for, I believe, the CLI platform. What you're asking is essentially a platform-specific thing. It's one of the things that is not a feature that needs to be implemented at the Roc compiler or the Roc language layer, and is instead the responsibility of the platform layer.
Sure. And then like the platform could give you like, because right now you are just like giving the platform a main function with some effects, right?
Yes.
But maybe the platform itself could also give you like arguments to your main function, right? Like some initial like flags or something like that.
Yeah, right now, exactly. Right now, main is essentially a task declaration, and if we strip away all of the complexity of the subtypes of this task, it's really just a task. In the same way that it could just be a string or it could just be a number. But instead, what that would do is it would turn it into a list of these string arguments, and then you give it a task back. So right now, I'm calling it a main function because I'm so used to working with main functions in other languages, but it's not actually a function here. It's just an expression. It doesn't depend on anything outside of it to decide what operations it's going to do.
Yeah. That's great.
So as we come up to time, I want to see if we can speed run something that resembles the core feature of that Book app, which is to say, if we have some, let's say, input file, and it has, some text, and then it's got some, breakpoint here, or let's say injection point, and then other text. What we want to do is have this second injection txt file, which is put me in, coach. And what we want to end up with is the contents of this file injected inside of this other file in the middle. That was one of the things that it may not be clear to other people on the call, but the idea was that if you had template files, we could rename this input file as template.txt, and we could rename this injection as content.txt. And now let's clean this up to be template goes here, or content goes here rather. And then we've got the content file, which is I am the content. Now, we want to put this content in that middle line of the template file. Sound good? So what we're going to do is we're going to first read we've got our template file we're going to need to define, which is local path template.txt. And then we've got our content file, which is going to be content.txt. And then let's call it our render file. render.txt, a file that does not yet exist. And we're going to read from both template and content. Read UTF-8 from template file, and we're going to read UTF-8 from content file. And this is going to be the template, and this is going to be the content itself. But this is not an equals. This has to be a backpassing because this is an asynchronous operation. But now that we've got our...
You should change that to read on the content line.
Thank you very much. We've got our template, we've got our content. Let's go ahead and just write out the concatenation of this template and content without doing any fancy injection or splitting or anything. Let's write that out and say, actually, all of this should be wrapped inside of this task assignment. Task is that we're going to read the template, read the content, and then write the render file with, let's say, what our render equals. Our render can equal template and then the content, just for simplicity's sake. For now, we'll have it be this. Up in my history until I find, there we go. We'll use Roc Dev so that we can catch any fun errors and fun type checking warnings. Okay, the output says that it successfully wrote a string to out, but let's instead say successfully rendered. And let's check, do we have the render.txt? We do, and this is the render file. So first it's that template content, and then we've got that content. So now let's change that so that the content gets injected into the middle. And Roc does not yet have any functionality for regular expressions or matching and replacing. So instead, what we're going to do is we're just going to use split functionality, and we'll hard code the fact that content goes here in the spot where it says content goes here. So we're going to have the before and after equaling string.split first of that template content with that string content goes here. So we're going to split that, we're going to get the before and after, and then we're going to have the before and then the content and the after. And I'm sure that I made some built-in mistake of using it improperly. Yes, I have. String.split first. Yep, it returns a result. So the issue with this is that maybe it doesn't find that string, that substring. What do we do in that case where we don't find the substring? Well, in that case, we're going to have before be the entire template and after be the empty string. That's going to give us before and after variables no matter what. Even if it fails to find that substring, it'll just put that content at the end of the file. Now we got the render and we get I in the content. But we did not, yes, success. I forgot to put the new line, so I went with the nitpick edit there. We want to actually substitute with a full new line since the content we're injecting has a new line at the end of it anyways. Now let's try it again. Now we've got the thing that I wanted to see, which is we've got the content in the middle. So with this, you can imagine extending this to be, normal templating syntax with some sort of angle brackets, input file 1 here, input file 2 here. It will be, a little bit more complex code to have it, take whatever, like if the template was saying file1.txt goes here, then it's a little bit more complex to say, okay, well, what is file 1? But you can do that. You can split it. You've got the before and after. You could do a split on either angle bracket and then get that file1.txt, and then you could do a file.read UTF-8 on the middle chunk, something like that. So there are solutions there. It's just a little bit more complex since we don't have regular expressions or anything, but it should theoretically be doable. And if you have any trouble with it, please hit me up because I have a feeling that you might be doing this as an exercise for the reader, George.
Yeah, definitely. Well, thank you so much, Jen. This is actually super impressive. I've been following Rock for a while now, but just like by following the Zulip, I haven't actually had the sense that it's kind of like ready for anyone to tinker with it. You know,
Yeah.
it's yeah, like it's like you said, like it's missing a few things that can live in the user code. Like you can just like be creative and deal with the fact that we don't have like we will never have a regex from what I've read.
Yes.
Yeah, but like maybe you can start building a parse or anything like that.
Yeah.
So yeah, really
Exactly.
really
Like
great.
a parser would be helpful here, but
Yeah.
isn't strictly necessary for all use cases.
Yeah.
So yeah, this is a whirlwind tour of what is currently working. But personally, I think that enough is currently working for it to be used for a lot of different applications.
Yeah. And just to clarify on regex, right? So probably the most reasonable way currently to add regex would just be to add it to a platform, right? You modify the CLI platform, you expose Rust regex, for example, if you wanted to, and have it return something.
Yeah.
But of course, long term, someone could make a regex module in Rock, and it should be able to be pretty performant. So
Yeah.
Nice.
Yeah. Maybe there's a pf.regex and then there's a regex find or replace or something like that. It's just that it's not. There's no plan for it to be a built-in. Like
And now maybe I'm drifting a lot from the main subject, but like you said, Brennan, someone maybe they will create like a regex in Rock itself, and it will be performant. But if you are not dealing with a platform, you can't actually go into the whole. Oh, okay. So yeah, Richard just said that if you do it from the platform, it needs to be a task. If it's just like Rock, maybe it's a whatever, right? Like a result or anything like that. But I was just wondering, like, if you are not making a platform, you can't actually go into the nitty gritty of okay, I want to do the in place notation or things like that, right? Like you have to rely on the raw compiler itself being as smart as it can, but you're not doing these things yourself, right?
that's correct.
I guess I have to be careful how I answer this because I make Rock do in-place mutation all the time, but I know how Rock works. And so for an
Yeah.
end user, Rock will try to do in-place mutation all the time, but like you might accidentally do things that, mess that up. And so then it ends up doing copying and suddenly your performance falls to pieces. But Rock is capable of doing in-place mutation when something's unique or like, doing a single copy at the beginning, making it unique, and then the rest of the chain being in-place mutation.
Got it.
But there are things that can end up screwing that up.
Yeah.
And so that it
So
should be capable of being very efficient due to our in-place mutation. Yeah.
got it. So maybe like in the future we will have like a rock review or something like that that can warn you when you are like just like doing your actual code in a way that is not giving rock what it needs to be as smart as it can, right? Similar to what we do with tail call optimization in now.
Mhm.
Got it.
Yeah, that's definitely something that I want personally because one mutation can end up ruining performance. And there's like we've talked about a few different ways to do it, but there's nothing solid here yet.
Awesome.
Sweet. Well, I mean, there's lots of new features we could add to this app. There's lots of cleanup that we could do and other things to explore with Rock. But I feel like considering that we're already over time for today and we've gotten to something working, maybe this is a good break point for here. And if anyone in here wants to do another one of these sessions in the future, I am very up for that. So let's chat in the Zulo chat about making a new one happen.
Thank you, Jen.
Thank you all. Have a great day.
Wait, before we go, can we give Jan a big round of applause? Because that was awesome. That was really sweet. Like, I really enjoyed, like, this watching someone who's not me, like, explain Rock to viewers. I thought you did a great job. So,
Thank you.
yeah, thank you so much for doing this.
Thanks. It's been a blast. It's fun to like, share with people the app dev process because the app dev process can be very like, I did it, crickets. No one on the internet knows how to write the Rock programming language. I can't share this with anybody. So it's nice to share it with people who are a little bit caught up on some of the syntax and the intricacies of why this is so cool.
Cool.
Yeah,
But
and if we
also,
Oh,
anyone has any questions, outside of doing one of these, there's lots of friendly people on Zulip who can help you out. There's a link to that in the Roc repo.
yeah, and if we want to do one on platform dev, I'd be willing to run something potentially, or we can do something
Nice.
else too, because I know that's another hairy subject.
Yeah.
Though Glue makes it a lot easier as long as you're willing to use Rust. So
For now.
Is this considered a meetup? I don't know what the noun for this would be.
maybe. Okay, I think I'm gonna stop the recording now, and hopefully everything goes well.